Hello everyone, this is Tom from Tutor Bros. Today we're going to be looking at special cases of multiplying polynomials. Now there's all different kinds of special cases to cover. We're just going to go over 3 specifically today. So let's take a look at each one in turn. The first one would be a plus b squared. So if we're squaring a binomial and we're adding the two terms together, the product will always exhibit the same pattern, namely a squared plus 2ab plus b squared. So that means that the product will be a trinomial where the first term is the square of the first term in the binomial, so that's the a squared portion, plus 2 times the first and the second term multiplied together, so that would be 2ab, plus the square of the second term in the binomial, and that would be the b squared portion. So there's a lot going on there, but why don't we take a look at an example problem and see how this all works out. So let's say we have x plus 4 squared. So this is modeled after number 1 here. So if we want to evaluate this expression, what we do is we take the first term in the binomial, which is x, and we square it. So that'll give us the first term in the trinomial product. Then to find the second term, we multiply the first and second term of the binomial, namely x and 4, so that's 4x when we multiply, and then we double it, or multiply it by 2, to get 8x. And then to find the last term, we take the second term in the binomial, namely 4, and we square that, which gives us 16. So the square of the binomial x plus 4 is equal to x squared plus 8x plus 16. Okay, now let's take a look at number 2. So we have a minus b squared. Now this is almost exactly the same as number 1. The only difference would be that the sign in the binomial is now negative. And the only way in which that affects the product is that the middle sign here, or the sign of the middle term, would be negative, but everything else stays the same. So we'd have a squared minus 2ab plus b squared. So let's take a look at an example problem modeled after number 2. So we have x minus 5 squared. And again, this is modeled after number 2. So in order to find or to evaluate this expression, we take the first term, x, and we square it to get x squared. Then to evaluate the second term, we multiply the x and the 5 to get 5x, and then double it to get 10x. But in this case, since the binomial has a negative in the middle, then the middle term in the product is going to be minus 10x. And then to find the last term in the product, we take the second term in the binomial, in this case that would be 5, and we square it to get plus 25. So the square of x minus 5 would be x squared minus 10x plus 25. Okay, let's take a look at number 3 now. So this one's a little bit different from the first two. We're not squaring a binomial. What we're doing here instead is we are multiplying two binomials together, where the only difference between the two is that the sign in the middle of the binomials is different. So in one it's positive, in one it's negative. And when we multiply these two kinds of binomials together, it will always yield the same product or product pattern, namely a squared minus b squared. So what that means is that if we're ever multiplying a plus b times a minus b, whatever a and b might be, the product will be the square of the first term minus the square of the second term. So let's take a look at an example problem. Let's say we have x plus 8 times x minus 8. So again, we have two binomials where the only difference is the sign in between the two terms. So one has a positive, one has a negative. Now, if we take the information given up here, we know that the product is going to be the square of the first term minus the square of the second term. So the first term would be in either of the binomials would be x, so we can say x squared. And the second term in each of the binomials is 8, so if we square that, we get 64. So x squared minus 64 would be the product of x plus 8 times x minus 8.